Okay, so first of all, on your notes, it says 3-1 up here, but that should really say 3-2, so you should fix that first. I already made copies, and I don't want to make new ones. Hopefully you realize from the assignment that we did that graphing isn't the best method. Why do you think that's true? Hopefully you said because if it crosses at a fraction, it's really hard to tell, right? Like if it crosses, if this is the xy axis, and they cross, oh my gosh, that was terrible to draw that first. So if you had one line go through like this and the other line come down like this, it's really hard to know that point, right? So algebra is what we want to do. So we have two methods to do this that hopefully you remember. One of them is called the substitution method. And the substitution just says that if you solve one equation for the other, then you can substitute it into the other equation and then solve it. Substitution you do all the time. If I said x equals 2, then what does x plus 7 equal? Well, you substitute that in and say 2 plus 7 equals 9. We're going to take that idea and use it with two equations. So if I said solve this equation using substitution, we want to be able to solve this for either x or y. The problem is right now you can't solve an equation that has both x and y in it. So you want to solve, step one, solve one equation for one variable. So pick which variable looks the easiest to solve for. Usually it's the one that doesn't have letters in front of it. So like I'm going to solve for x, which means what I'm going to do is I'm going to subtract 2y from the other side, and I'm going to get x equals 8 minus 2y. So that I can do step two, which is, step two is take that equation and substitute it into the other equation. So if x equals this, can I take it and substitute it in for x right there? The answer is yes. So I could say 1/2, and instead of x equals 8 minus 2y minus y equals 18. And now what do I have? I have an equation that all has y's in it, so I can solve that. So half of 8 is 4. Half times negative 2 is just a negative 1y, or negative y. And I'm going to leave everything else the same. So we still have to be able to solve an equation. These y's are on the same side. So if I have negative 1 and negative 1, that's negative 2y. And if I solve that for y, I'm going to undo adding 4 by subtracting 4. And that would leave me negative 2y equals 14. Divide by negative 2, and I get y equals negative 7. But remember, what is a system of equations? Solution, it's where the point where they cross. So just having a y is not the answer. We also need an x. So we can substitute this back into the original equations, or I think it makes sense to plug it back up here. If x equals 8 minus 2y, and we know y equals negative 7, then that's 8 plus 14, which is what, 22? And you can leave your answer like this, or if you want, you can write it as an ordered pair, which means this would be one I really wouldn't want to graph because it doesn't cross until the x is at 22 and the y is at negative 7. You can check that this works just like with the graphing ones by plugging it back into both equations, and if it works in both equations, then you know for sure that it's true. So what about this one? This is where you have some choices of what you want to solve for. I would say you should either solve for this y or this x, because you don't want to have fractions, right? Fractions make things a lot worse. So I always solve for one that doesn't have a number in front of it. So if I was going to do substitution on this one, I would get this x by itself because it's the easiest. So I would subtract 4y over, and I get x equals 11 minus 4y. Then what's my next step? I'm going to take this, and I'm going to plug it into the other equation. I'm going to substitute it in for x. So that becomes, instead of 3x, it's 3 times 11 minus 4y minus y equals 7. And your line here should only have either x or y in it, not both. Excuse me. And now if I distribute, I get 33 minus 12y minus y equals 7. And again, these y's are on the same side, so don't like add y. You're just going to put them together, which would be negative 13y equals 7. And then you're going to solve that equation, which means that hopefully you're going to subtract 33. And that would give you negative 13y equals what? Negative 26. And then you divide by negative 13, which would give you y equals 2. Again, you're not done yet because you have to also find x. So we know that x equals 11 minus 4y. So that would be what? 11 minus 8, which is 3. And you can say x equals 3, y equals 2. Or you could say the ordered pair 3, 2. So we're going to leave this one. You could go ahead and start thinking about which letter you want to solve for. And we'll do this one in class so we can do a substitution together. Because the other thing I want to talk about, and maybe you remember already, is that the other way to solve a system algebraically is to use something called elimination. And elimination is where you eliminate one variable by either adding or subtracting the equations. And so again, that gives you steps. Step 1, multiply one or both equations by a number to result in two equations that contain opposite terms. And then add the equation, eliminating one variable. Then solve the equation and then plug it back in to find the other one. So let's do an easy one first, okay? So you could totally do substitution here, but I think elimination is better because look at these x's. Since they both have a 1 in front of them, what if I just subtracted these two equations? And what I mean by that is what if I just draw a minus sign here all the way through and I subtract like the old days, like top to bottom. So x minus x is 0x. We eliminated it. 2y minus 1y would be 1y. And 10 minus 6 is 4. And oh my goodness, right away we know that y equals 4. But just like in substitution, we still have to find x, so we have to take and plug the 4 back into one of these two equations. And I'm just going to do the bottom one, x plus y equals 6. So if I know that y is 4, right, you're just going to say then that means x equals 2 as my answer. And if I graphed that, that's the point they would cross at. But maybe you remember from Algebra 1 that it's not always so simple, that sometimes you have to multiply to make them the same. And this is where you have choices. And this is where I have to just kind of check your work because you might do it differently than I would do it. But here's what you have to decide. Do you want to eliminate your x's, which means do you want to make these the same so you can add and subtract? Or do you want to eliminate your y's? And sometimes there's an easier answer than others, and other times it doesn't matter because it's the same amount of work. So you just have to decide, all right? So I'm just going to make a decision, and I'm going to make my y's the same number, which means I want to make these the same number. And the first number that 3 and 2 share in common is 6. So what could I multiply this top equation by that would make this a 6? That would be a 2. And what could I multiply the bottom equation by that would make this a 6? It would be a 3. And as long as we do it to everything, we haven't really changed the problem. So this becomes 4x plus 6y equals 24. The bottom equation becomes 15x minus 6y equals 33.
Can I write?
What color do you want?
Green. Rainbow,
And so then we have to make the same decision of we have to say, what am I going to do to eliminate my variables? Well, now they're both 6's, but notice one's a minus and one's a plus. So to get those to cancel out, I just have to add the two equations, right? Because 6 minus 6 is already 0. So 4 plus 15 is 19x. And 24 plus 33 is 57. You can't make noise while you're doing it. Divide by 19, and I believe that works out really nice to be 3. This would be one that would be really ugly to do substitution with, and so it's where elimination, I think, maybe is the best method. But we're still not done, right? We did a lot of work already, but we still have to find what y is. So we have to take this, And we can plug it back into this equation, or this equation, or this equation, or this equation.
Green crayon, green crayon.
And you have to find y. I just usually go back to the original. It doesn't really matter which one. I'm just going to plug it into the top equation. So I'm going to get 2 times x, which is 3, plus 3y equals 12. And I'm just going to solve that. So 6 plus 3y equals 12. If I subtract 6 over, I get 3y equals 6. Divide by 3, and I get y equals 2. Or again, you could write it as the ordered pair, 3, 2.
What just happened?
I don't know, you erased it. All right, I got to change it. So now, I think this is the last one. Think about on this one which one you would multiply by, or would you want to get your x's together or your y's together? And again, we'll save this one to do in class.